Welcome back, everyone. This is going to wrap up our section on how to best design, implement, and manage virtual network routing on Azure. Before we move on to our next section, let's once again review the primary topics we covered in this section and also go through another case study scenario before we move on. We started off as usual with a high-level overview of how exactly routing works on Azure, in which we started with the fundamental concept of routing is simply the process of a computer selecting the best path from its source to its destination. We then turned our attention to Azure by discussing the two different route types we are most concerned with, which include system or default routes, which we cannot edit, and also user-defined or custom routes, which we can create and edit. And we also broke down the components of both system and default routes, which include the source, in other words, what type of route it is, the address prefix, in other words, the where am I going, and the next hop type, which is again, how do I get there? We then turned our attention to taking a closer look at creating custom or user-defined routes on Azure, in which we learned that these custom routes have the ability to overwrite or essentially replace our default routes, of which the classic example that we focus on was that of forcing outbound internet traffic through some sort of a network virtual appliance. We then covered the process of how to implement a custom route, and then covered how Azure chooses between default or custom routes, in which it will start with address prefix length, in which the higher address prefix wins. In a case of a conflict with address prefix, it then goes to route type, in which case the priority order is custom routes first, then BGP routes with system or default routes at the bottom of the priority order. And we finished up by discussing the number of ways to troubleshoot routes, which include viewing effective routes and also including a couple different network watcher services to help troubleshoot as well. Next, we focus on a quick, deeper look on how forced tunneling works, in which we learned that forced tunneling is simply the process of forcing outbound internet traffic through some sort of a gatekeeper, which could be either a VPN or a network virtual appliance device. We then took a look at the VPN-specific scenario, in which we learned that an additional step is required of setting a default site, which can only be accomplished in PowerShell, and there was a very specific command that you should know going into the exam. And then we finished things off with a quick high-level overview of a relatively new managed service called Azure Route Server, in which we learned it is able to dynamically or automatically update routes between some sort of a network virtual appliance and the virtual networks that connect to that appliance, from which we took a quick look at a couple key points of how to implement the service, in which we learned that the service requires a dedicated subnet that also has a specific naming requirement, which was once again a review of our previous subnet delegation concepts. Moving on, let's wrap things up with revisiting once again our favorite case study scenario of our fictional bakery Control-Alt suites. In this scenario, we have two specific requirements that we want to meet. The first scenario with our fictional bakery is that we need to properly secure outbound traffic through a virtual appliance, in which for security and compliance reasons, there is a need to inspect outgoing traffic through some sort of a firewall virtual machine. And in our other scenario, with our firewall virtual machine, there is a need or at least a desire to automatically update new routes that are always being added to this machine. In other words, once new subnets are added or modified, we want to be able to automatically update those route tables for use by our virtual appliance or our virtual firewall, so we don't have to manually do it ourselves. So for this case study scenario, go ahead and actually pause the video for a quick second and think about the specific steps from our previous discussions that would go ahead and fulfill both these requirements. Once you've thought about the proper solution, let's go ahead and move on. Let's go ahead and think about our first scenario, in which we need to secure outbound traffic through some sort of a virtual firewall. From our previous discussions, we learned that the proper method to accomplish this is to create a user-defined or a custom route for our outbound traffic, which from an implementation perspective was essentially a three-step process, in which we start by creating a route table, and then inside of our route table, we can create one or more custom routes, from which we learned that our custom route has a few essential components. One is the address prefix, again, the where are we going. In this case, with internet-bound traffic is all zeros. We then need to assign a next hop type, in other words, how do I get there, which is going to route through or force tunnel through a virtual appliance. And in the case of a virtual appliance next hop type, we have the additional requirement of supplying a next hop internal IP address. In this case, we just made up one of 10.0.1.4. And then our last step in the implementation process, once we have our route table and our custom route, we then need to associate or assign a subnet with that route table so the custom route will automatically apply to all resources inside of that subnet. Next, let's talk about our dynamic routes scenario in which we want some sort of a service to automatically update those routes for us. Again, from our previous discussions, the Azure Route Server service would be the correct tool to accomplish this. In which case, we would take a virtual network, we would then create the Route Server service inside of that virtual network, from which we learned it has a specific subnet naming requirement of Route Server Subnet. And then once we have our subnet and the service deployed, the next step is to peer or associate our Route Server service with a virtual appliance over BGP exchange, from which our Route Server service will automatically detect and update all of its routes and subnets within its scope, which by default is its own virtual network, although you can peer it with remote networks as well. So with that, that's going to conclude our section on routing on Azure. Let's go ahead and move on to the next section in which we are going to discuss how to connect Azure Virtual Networks together with network peering, and I'll see you in the next section.